Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video on research potential series, I want to talk about research potential on heavy pressing. Okay, this is for those who are interested to do master, PhD, and maybe final year project on this topic. This is the video for you. The research potential on heavy pressing. So, what is an heavy pressing actually? Okay, heavy pressing can be defined by uh, some of the materials, some of the machine. Among them are heavy press forge. If you have the forging machine, you want to press. Okay, the press power is beyond the capability of a normal universal testing machine because this machine named UTM, Universal Testing Machine. Okay, or known as UTM machine. All university, all technical university must have this machine. This capability of this machine is only 300 ton, 300 ton plus. Normally on 300 ton, it may go for high mass machine for 500 ton press. Press. Okay, but what happened beyond that? Okay, what happened beyond that if a machine university level, most of the university level don't have machine that can press beyond 300 ton. Okay, you have to do heavy press machine. Okay, you are using forging machine. Okay, maybe you have to go to industry and maybe you have to go to somewhere else to do the to get the equipment to do the research. Okay, so this is among the challenges you have to do in order to do this type of research. Okay, not many are doing heavy press machine. Okay, especially on focusing on microstructure, uh, fo- focusing on microstructure, or and also if you are talking about heavy press machining using uh, explosive compaction, explosive pressing, there are very few institutions that want to do this kind of research. So, uh, among the researchers have done, okay, on heavy press machining, biopolymer in cement industries, powder metallurgy of nickel super base alloy, okay, investigation of microstructure and mechanical properties of surfacing layers of hot forging, okay, temperature field and thermal cycling characteristic, manufacturing of components from titanium alloy. This is among the greatest achievement from heavy press machine. Okay, about heavy press machine, uh, countries that have uh, their military power, that can build tanks, they can send people to the moon. They have heavy press machine in their country. Other countries don't have this machine. This machine is reported can achieve 80,000 ton press. Okay, it can achieve up until 50,000 to 80,000 ton press. This is called heavy machine. Heavy machine. Country like Malaysia, we don't have this machine. Countries like USA, Germany, China, they have this machine. Okay, so that they can build armor tank, they can send people to the moon because they have this kind of machine. They can press so many pressing power. Even titanium can be pressed. Titanium, even titanium, the hardest material, titanium, it become layer of pancake. Okay. So this is if you have this capability, very good to you. Okay. Uh, so among the problems, even the people can study this approach to forging. Okay, forging around 1,000 ton. Okay, 1,000 ton press. If normal operation for other countries that don't have this 80,000 ton machine, you can do forging. Okay, forging also can reach about nearly 1,000 ton press, uh, 8 8,000 ton press is within the range of forging machine. Okay, so multiplication, so additive manufacturing, increasing the strengthening of microalloy steel, for instance, X-ray diffraction, hardness of echo samples. And this is among the problem that people want to study on heavy press machine. Okay, and this is the original objective. Okay, forming process, unsolidated powder super alloy. Okay, low forming quality, varieties of aluminium. Some people want to study the material itself. Okay, uh, cracking behavior. Of course, when you are pressing, uh, depending on how fast you press. If you press faster, if you press so fast, cracking may happen. If you press slow, it will material become smooth. Okay, become harder. So this is what you want to study. Okay, and then this is the expected result. Show that newer non-steel material, maybe some property of material can change. Okay, and then this press velocity also mean the play the factor depending on how fast and how slow you press the press rate. Okay, the application finish aircraft bracket. Maybe some research want to, because advantages if you have the material that machine that can press very powerful press, very high level pressing, you can press any kind of material. So your material, you can become strong. Okay, this is the advantages. Okay. So this is the research methodology. Okay, if you are interested in doing this research, this is among the tests that you may encounter, you may use. Okay, maybe you will not use any some of them, but most of them you may use. Discuss with your supervisor. Okay, they are the qualitative test, test compression test, viscoelectric test, mechanical test, forging test, unit axial tensile test. This is a method, forging method, innovative method, traditional processing. Okay, and then this is a major measurement that you have to encounter: hardness measurement, micropillar compression, ESB measurement, spring device. Okay, uh, this equipment, large project equipment, of course. Okay, large project equipment you must have. Maybe your university don't have, maybe you have to work out with industry. Okay, uh, heated tools, equation of stress, equation, consistent equation, Avrami equation, billet model, simulation model, field element model, heterogeneity model, BCJ model. This is when you want to seriously go into for this research, you must learn. Okay, you must learn by yourself what is this equation, Avrami, billet model, and everything. It will help you a lot. Okay, this is the properties that you may use most of them. Okay, this is the crack that may happen during the process, the micro crack, the delayed hybrid cracking, cluster hybrid crack propagation. This is the microstructure test, viscosity, pseudoplastic properties. Okay, this is some of the experiment that you may use: isothermal forging, compression, oil displacement, oil compression. This among the analysis: finite element analysis, mechanical property analysis, transmission electron, failure analysis, microstructure analysis. So much analysis that you have to do. Okay, uh, using this video, you may not miss most of the experiment. Okay, and then the morphology, particle morphology, globular morphology, deformation, plastic deformation, hot deformation, deformation temperature, and then the strength, tensile strength or side strengthening mechanism, fracture strength, prediction. If you are using simulation, you may predict temperature change. Okay, uh, casting metric of the automobile crankshaft if you are interested to doing in automotive industry. Okay, approach for PVD approach, mode of fracture mode. And then micrographic, photographic, crystallographic, atom probe tomography, rate, strain rate, shear rate, high energy rate forging, cooling rate, nucleation rate, detects, crack propagation rates. Okay, this is the model system, die heating system, tool heating system, multi-layered system, technique control system, scanning electron microscope. Okay, it is software that may help you, computer engineering software, deform software. Okay, this is a model list of abstract. There are many more. If you are interested to do this kind of research, you can get the full link of the PDF document at the description below this video. Okay, so again, doing research is not that easy. It's also not that hard. If you, as long as you know the technique to do this research, to do any kind of research, you may be successful. This video may help you a lot. Okay, I have done analysis. My student helped me to do this analysis. Uh, just want to help you to do this analysis. You may not miss a thing because we have analyzed most of the content on the journal. We have listed out the material, the equipment, the tools, the software. When you are doing this research, you seriously want to do this research, you see this video, you may not miss any research material. Okay, your supervisor will be impressed. Okay, so I wish you the best. I wish you all the best. Okay, good luck in your study. Okay, thank you very much.